Good morning to all. Myself Professor Archana from IIT ISM Dhanbad. We are in course of Introduction to Python and Petroleum Data Analytics. We are in week 12 where we are discussing unsupervised machine learning algorithm. We have already discussed under the unsupervised machine learning ML, we have discussed k-means. Now under the clustering, under the supervised clustering concept, we are discussing the another algorithm, that is hierarchical clustering. So this I am going to start today. So before that, under the unsupervised, we have talked about the k-mean. So how it works? Here what we are doing, we are dividing data into a specified number of a non-overlapping cluster. So k is the number of cluster. Okay, so if you do have 100 data points, okay, what we will be doing, we will be we can take, okay, 100 centroid, we can take it, and slowly how we do calculate the distance, okay, and the smallest distance between the 2 points, we club it and we form the cluster. This all discussion we made it in our previous classes. So what we are doing basically under the k-mean clustering, dividing data into a specified number of a non-overlapping cluster, minimizing the distance between the data point and their assigned cluster centroid. Okay, so this is the one thing we know. If you do talk about the pros and cons, okay, so the pros is it is efficient and fast, okay, that means it is suitable for a very large data set. And then next, uh, guaranteed convergence, so we will always find a solution. If we do talk about the cons, so what required here in k means we require to predefine the value of a k. Okay, so number of a cluster must be known before running the algorithm. So that is the one thing which is considered cons here, because we require to predefine the value of a k. Now the second one, it is insensitive to initial centroid. So result can depend on your initial placement of a cluster center. And then lastly, we assume spherical cluster in case of a k-means. So it does struggle with the cluster of a non-spherical shape. So here these 3 points, okay, leads to the looking for new clustering algorithm. So one of the another clustering algorithm, that is hierarchical clustering, which I am starting today. Okay, so what is this hierarchical clustering? So first thing, it is a unsupervised learning technique, and it is used to group similar data points into cluster. So whenever we do the clustering, what we are doing, we are grouping the similar data point, okay, and building a cluster. Okay, so in this particular, in the hierarchical clustering, what we are doing, we are grouping a similar data points into cluster by building a hierarchy. So here what we are doing, we are building a hierarchy. Hierarchy, that means tree like a structure we are making it. So previous one, the one we do talk about the k-means. Okay, so this k-means, unlike flat clustering like k-means, hierarchical clustering does not require specifying the number of a cluster in advance. So that is the benefit of using your one of the benefit of using your hierarchical clustering. So here predefined value of k is not required, okay, and that was the flat clustering. So if we do have a data here, so like that we are making cluster, okay. So here we do not see any tree like structure, but in case of your hierarchical clusterings, when we group similar data points into cluster, how we do that? By building a hierarchy, okay. And the third, that algorithm builds cluster step by step, either how it is doing, the two way it is being done, okay. One way of hierarchical clustering is your algorithm, and the another one which we do have, it is a your divisive. Okay, so two type of clustering under hierarchical clustering we do have. One is the algorithm. So algorithm we do talk bottom up, okay, and then divisive we call it top down. Okay, so what it means, we will come back to that one. Okay, So the algorithm build cluster step by step, either by progressively merging smaller cluster. So progressively building, merging smaller cluster, that's the one algorithm. Okay, and then another one by splitting a large cluster into a smaller one, that is your divisive. So the two thing here, either we are merging the smaller cluster and making a big one, or either hold the data point, we do consider it is a large cluster and then we are breaking down into the smaller one. So two approaches we do have under the hierarchical clustering. One is merging the smaller cluster, okay, and the second one breaking down the larger cluster into the smaller one. Okay, so this process, when we do this process, is often visualized using a dendrogram. So one thing here, we do talk about the dendrogram, and this dendrogram which helps to understand this data similarity. So we have seen how the hierarchical clustering we see till here. It is not only valid for your spherical data. So this the one you can see. If you have the data like that, easily you can apply the k-means. Okay, but if I do have a data, it is not spherical, or we can call that non-spherical. Okay, so this is the what non-spherical data. If there is, okay, it would be difficult to go ahead with the k-mean clustering. In that case, what we are doing, we are using the hierarchical clustering. Okay, now see this the one we do talk. Okay, hierarchical clustering. Okay, so the point here we are clear, no need of k, predefined k, predefined k. Okay, then two approaches we do have. One, merging small clusters into larger one, or big larger one. Okay, that's the one. And under this second one we do have breaking down a larger cluster into smaller one. Okay, one more thing, there is something called, we do talk about here, dendrogram. Okay, dendrogram. So what it gives me? Visual representation. Okay, and then hierarchical clustering, we do have a tree like structure. Okay, that is a dendrogram we do have. Okay, so that is your tree like structure. So this the 4 points we do see. Okay, and one more, it is applicable for non-spherical, uh, when you have data clustering in like non-spherical. Okay, so that time when you distribute the data and you find it is not spherical, you cannot easily make the clustering, we call that non-spherical, and then this hierarchical clustering is going to help you out. Okay, so this is the couple of the things. Okay, now we have here this the approach. Okay, uh, algorithmic and this divisive. Okay, so that's the one we are going to start talking. So the two way, so this algorithmic is the more commonly used approach, where what we are considering, each data point start as a single cluster and pair of a cluster are merged as one moves up the hierarchy. Okay, so this just take it here. Okay, so let's see this clustering how it works. Okay, so if you do have the 4 point here, we do have the 4 point. So what we do first, the one which is near one, so we do calculate the distance. Okay, so assume this is A, B, C, D, E, F. So this is the one. Okay, so first let's see how it works. Okay. So so A, B, C, D, E. Assume one more point F. Okay, and this A, B, C, D, E, and then take one more point F. Okay. So initially what will be done? Distance between the 2 points required to calculate, and then the smallest distance between the points we are going to merge and make the bigger cluster. So initially in the hierarchical clustering, if we are going ahead with the agglomerative one, okay, so each data points, okay, if you will take this one, each points are one cluster. So first what we are taking, each point is a one cluster. So if it is a one cluster, so what we have to calculate, we have to calculate this distance matrix, we can call that. So this is nothing but my distance matrix, we can call this one. Okay, so we require to calculate between the each point. So initially between the each cluster, so this itself is a one cluster, so distance between A and A would be what? It is a 0. Then there would be some distance here between A to B, A to C, A to D, A to E, A to F. There would be some distance, which some numeric value I am going to put it here. So that's one thing here. Distance, where I mentioned the distance. In the last class, we do talk about the distance, how we do calculate. So there is a different way we do have. One is the Euclidean distance. So assume we are calculating the Euclidean distance, which is the most commonly. Okay. So initially when you have the data point, individual data point, we are calculating the Euclidean distance. Then we do have the Manhattan distance. Then we do have the other distances also. So assume one distance we are using the Euclidean distance or Manhattan distance you are taking and calculating the distance. So distance was calculated. So between each data point. Okay. So this the A point. I am calculating the distance of A with respect to B and the all. So total I have the 6 point. So I am calculating the distance, and but distance between A to A, it is a 0. Now I am going to the second one. So here it will be some distance B to A, but A to B, B to B again 0. So like that. Similarly, when you go here, C to C 0, other, then D to D 0, other will have some distance. Okay. Now E to E 0. So like that you will keep. Okay. Similarly you have. Okay, here 0. So this distance, it is a always 0. Okay, so this point to point distance is you have the 0. So A to A distance is 0, B to B 0, C to B. So this is my distance matrix calculated. Now what I will be seeing from this distance, we will be looking for the 2 point, which is a based on the distance, which is the nearest one point. Okay, so assume these 2 points. D and E distance is the minimum. Okay, so A to D distance is the minimum. So what I will be doing from this diagram, you take A to B distance is minimum. So A to D distance is minimum. After the calculation we find it out. So I am going to merge these 2 points. Now this is what? This is my cluster 1. Okay, so now this is nothing but my cluster 1. So now this cluster 1 distance, now one more distance matrix I am going to have. Okay, and you can take it here. Okay, so now one more distance matrix will be calculated, where just add one more page here. So let's add it. Okay. Now I explain you. Now from here what we are getting, um, these 2 points is having the less distance, so we do make this 2 together, and now we have the one cluster, and that we are calling the cluster, first cluster. Okay, now how many points? Total 6 point we had it, now it has reduced to 5. So this is the one. Then we have the still 4 point, okay, separate point, single points, and we do have one cluster which has the 2 points A and B. Now go to the one more formulation. Okay, so this is my cluster 1. Then the what the point left out, C D E F, C D E, and then we do have it. Okay, so that's the now we do have. Now you will be calculating this the cluster value. Okay. So C D E and then F. Now again the same thing I am going to calculate them. So C to C distance is 0. Okay, and then it will have some value here, all will have some value. Now C to C distance, okay, that will be C to C1 distance, it will have some value, but C to C distance is 0. Okay, and the rest will be as the previous one, because C to D distance has not been changed, C to E distance not been changed. Okay, now similarly what we will have here, 0, okay, because D to D. Now E, similarly we will have something, then F we are going to have something. Now we require to calculate distance from cluster 1 to C, cluster 1 to D, to all the data point. Okay, and the similarly rest of the distance would be the same. Again you will get here all 0. Now this is the new distance calculation, you made it. Now again you will be seeing which two is having the nearer. Okay, so assume this, the D is the nearer, okay, from the C1 or from the D1. So similarly one new cluster you will form, okay, and like that it will keep going till the point you reach to the one big cluster. So here we do have this diagram. So now you will be calculating these two are the nearest. Now you will find this three are nearest. Now these two are nearest. Now these all are nearest. So now you have this. Okay, so we do calculate the distance, okay, and shortest distance we club merge together, form a cluster. We again calculate the shortest distance, we merge. Like that we keep repeating till the point we make the whole cluster, or if there is some criteria given, okay, maximum number of merging or something, accordingly we do decide. So this is my algorithm. So initially each individual point I have considered it is a cluster, then we do calculate the distance between your cluster and your another individual point. Then again we do check what is the distance between the points, okay, and the smallest distance one we merge. This process we keep repeating till we reach to the bigger one. So this is your clustering. So what we learned it here, we required distance calculation, okay, and the another thing merging, okay. So let's get some more idea of this one. So here we are talking the algorithm, that is a bottom up, that just now I told you, and then there is a divisive, that is a top down. So bottom up, that means individual one I am going to make the bigger one. So individual one, initially it is each one is consider one cluster. So this all cluster I want to merge it. In the divisive one I have already that big one, okay. So based on this data dissimilarity I will be making the breaking down. Here based on the data similarity I am merging, okay. So this is the two things. So just repeat it again. So what in algorithm, it is a more commonly used approach where each data point is starts as a single cluster and pair of cluster are merged as one move up the hierarchy. Divisive, what we have seen, start with all data point in a single cluster and that progressively split into a smaller cluster. So this both your algorithm or divisive required a measure of a similarity or distance such as Euclidean or Manhattan distance, and there is one more thing, linkage criteria, which I do mention here, okay, about calculating the distance from the cluster to other point, okay. Initially point to point distance we are calculating, then we are calculating the cluster distance from the point. So if you have the point of these are the point under cluster 1 and now it has to calculate the distance from this point, so which distance will be calculated? So this is called your linkage. So this under the linkage we do have the 4 option, okay, minimum, maximum, that I will explain you, okay. So then after calculating this first we require to calculate distance, and the second thing what we required the linkage criteria. So under linkage criteria we do have a single, complete, average or ward method, and these things determine which cluster to merge or divide, okay. So based on that we are going to do this merging or division, okay. So if you take two together, okay, so this hierarchy clustering process, it is having the number of steps. So first, initialization. So in algorithm clustering, each data point is treated as a single cluster, and conversely in divisive clustering all data points are considered one large cluster. Then second one, distance computation. The distance between cluster is calculated using matrices Euclidean or distance for quantitative data or Hamming distance for categorical data. That's the thing. Then third point is a linkage criteria. This step involves choosing a linkage criteria that determine the distance between set of the observation as a function of a pairwise distance between observation. So we do have a single linkage, so that is a minimum distance between the cluster. Complete linkage, maximum distance between the cluster, average distance between the cluster, then there is a VAR, minimizes the total within cluster variance. So this single, that is calling minimum distance between the cluster. Okay, so if you do have the structure, so we require to take the minimum distance. If this is another point, okay, so what is that one? Minimum distance between the cluster. Okay, so that we call that single linkage. Okay, and complete maximum distance between the cluster. Now this is my cluster 1. This also single point I'm considering one cluster. So if we do have to find the distance, so this is the minimum distance when we do calculate. Okay, we call that it is a single linkage. So like that. Then cluster formation based on the chosen linkage, that is 4 option we do have: single, complete, average and VAR. So based on the chosen linkage criteria, cluster are formed by either merging by the closest pair of a cluster, that is your agglomerate, or splitting cluster further, that is your divisive. So then here comes the dendrogram construction. Okay, so a dendrogram is built to visualize the process of a cluster formation and to decide on the number of a cluster by cutting the dendrogram at a desired level. So how to do this activity? Just I will tell you. Then there is something optimal cluster selection. So the cut in the dendrogram is chosen based on the domain knowledge, the problem at hand, and using a objective criterion like a Silhouette score. Okay, so let's see this algorithm. Okay, so how we are starting individual point. Okay, so if you do have a 5 point, okay, each point will be one single cluster. Then we do calculate distance between every pair of the cluster. So then that I have shown you with the distance matrix. Then how we are merge the closest cluster, identify the two cluster within the smallest distance, and then merge them to a single cluster. So we are merging that way. Then update distance matrix, that's the one where this linkage comes into the picture. So after merging, we now have one less cluster. So what we do, recalculate the distance between the new cluster and remaining cluster, which I have shown you. Then we keep repeating this step 3 and 4. That means keep merging the closest cluster and updating the distance matrix until we have only one cluster left. Then we create a dendrogram. So as the process continue, we visualize the merging of a cluster using a tree-like diagram that we call the dendrogram. Okay, so it shows the hierarchy of a how cluster are merged. Okay, and with respect to divisive, what is the workflow of that one? Start with all data point in one cluster. So treat the entire data set as a single cluster, split the cluster. So what we are doing, divide the cluster into two smaller cluster. Okay, and division is typically done by finding the two most dissimilar point in the cluster, using them to separate the data into two parts. Okay, so there we are choosing the which two is the similar. Here what we are doing, which two is having the dissimilarity. Okay, so initial the big one we will split. Okay, so first we will see which is the dissimilar, so that we will separate, make it two, then again we will check and we will keep doing it. Okay, now repeating the process for each of the new cluster, repeat the splitting process and choose the cluster with the most dissimilar points and split it again into the smaller cluster. So this way what we do, finally stop when each point is in its own cluster. So this is my stop step. Okay, so here the another important thing which we are keep talking, that is the distance matrix. Okay, so here there are a how to come up with this distance matrix I do mention. So while merging two cluster, we check the distance between the two every pair of a cluster and merge the pair with the least distance or most similarity. So what we are doing it, calculating the distance and then merging the pair with the least distance we are doing. Okay, so but the question here is, how is the distance determined? So that's the important question here. So how is that distance determined? So there are different ways of finding intercluster distance or similarities. So that's the one we do. I mention that is a single linkage. Then this is the one we do mention it as a complete linkage. One is a single, it is a minimum linkage, complete linkage, that is a maximum linkage, and then average and word. Okay. So here we do have minimum distance. Okay, so minimum distance, what we mention, find the minimum distance between any 2 points of the cluster. Okay, so we do calculate that minimum distance and then we use that one. Either we can go ahead with the maximum distance. So find the maximum distance between any 2 points of the cluster. Okay, and then we check this group average. We go ahead with that option, and then we find the average distance between every 2 points in the cluster. Okay, so find the average distance between every point of the cluster. Okay? So we do calculate the average, then we that distance we take, use as a reference, and then calculate the distance from the another point. Okay, and then we do have the word method. So the similarity of the two cluster is based on the increase in the square error when two cluster are formed. Okay, so now let's see this construction of this dendrogram. So this dendrogram, I mentioned there is a dendrogram in your hierarchical clustering. So the dendrogram is a visual representation of your clustering process, and each merge or division is represented by your node. Okay, and the height of the node indicates the distance or dissimilarity between the cluster. Okay, so this figure represents how your dendrogram looks. Okay, so let's see this the one small example. So the main use of a dendrogram is to work out the best way to allocate the object to your cluster. Okay, so this is my dendrogram. So there is a 6 observation. Okay, and it is on the scatter plot here. So here what I do, as we make the clustering, we do have the same clustering visual representation on the dendrogram. Okay, so we do have here, you can see this E and F. Okay, it seems quite similar. Okay, near distance calculation as I mentioned. Okay, so E and F from this scatter plot, what we can see, E and F looks closer, A and B looks closer. Then you do have here this all looks closer. Okay, now I am taking that, and then finally I am taking this one. So this the one it has put it here. So E and F is near. Okay, so we do have dendrogram. In dendrogram it looks like that. Then we are merging with the D. So these two are being merged with the D. Now this whole cluster I am merging with the C. So this the all I am merging with the C. Now here A and B is a nearby distance, smallest distance. So these two merge together. Now this all we are merging together. So this is nothing but my dendrogram. Okay, now talking about this node. Okay, so this E and F point have been together at this label. Okay, so this is the one we call that node. Okay, now this two is, now this is the one cluster. So this has been merged with this D. So this all is merged here. Okay, so what we can see, there is just vertical distance we are talking about. So if this distance is less, that is the more similar. If this distance is less, that we are talking more similar. Okay, so in this diagram these two are the more similar. Okay, now we are talking about the number of clusters. So let's see, one code was done here. Okay, so this is for the hierarchical clustering. Okay, so first relevant library was imported. Okay, and again I am working with the Google Colab. So I have my data in my drive. Okay, so just I am importing from Google Colab import drive, and then I am mounting that driver.mount. Okay, and then I wanted to give path to a file in a Google Drive. So respectively I have done all this coding. You can check this, and if I have the file CSV file in the drive itself, we require to mount that one. So choose the file and mount it here, then you can work and there won't be any error. So let's see that I have the data. Okay, and that data in the CSV file, so I am reading that data. Okay, now next you can see that TF. So we do have the two columns. So it is having the 200 rows and two column. Okay. Now what we are doing again, we are working with the clustering. So we have to do this scaling. So from sklearn dot preprocessing, I am doing the standard scalar. I am doing in the scalar. Created the object and then standard scalar. Then we are fitting that one with this whole DF data. Okay, and then making this transformation. So this is the one thing. Now next what we wanted to do, import scipy dot cluster dot hierarchy. We wanted to import as a SHP. Then wanted to show this dendrogram. Okay, so for the dendrogram what we have to send, SCH is my what, scipy cluster dot hierarchy. So that dot linkage I am passing. Just now I do talk about the linkage. Here method I am taking word. So in the method I am taking what, you can keep it any, which we do discuss, maximum, minimum, single linkage and complete linkage. We do talk average linkage, and then we do have one word. So what I am taking, okay, method. Then we are passing setting X label, Y label, okay, and then title. So once you see this one, what you can see, this is the one we do have the dendrogram created. Okay, now next what we can do, one more thing we can do here. From sklearn dot cluster we are importing this agglomerate clustering. So this was my dendrogram formation. Now what we are doing, from sklearn dot cluster we are importing agglomerate clustering here. Okay, and then we are creating agglomerate clustering class, and object we are creating, agglomerative clustering object we are creating, and cluster we have given here 5. Okay, number of cluster 5, and then Euclidean we do have matrix we have given Euclidean and linkage word. So that we require to give, but the matrix we are using distance calculation, and then linkage we are given word. Okay, now we are fitting this DF scale data which we have already scaled, and that's the one you can see. This is your result for the data. Okay, now what else you can do here? Okay, the scale data we are passing, the column name we wanted to put it the same. Now I am adding one column, that is my cluster, and then each point you can see in which cluster it has put into. Okay, so total how many clustering we do have? We do have the total 5. I have put it here, and accordingly we can see in which clustering your data has put it. So this is about the coding part. Okay. So dendrogram concept we know, we get some idea of the hierarchical clustering. So there are the two type we learn. One is the bottom up and top up. Okay. So bottom to top and top to bottom. So that's where two we get the idea. So one is the agglomerate, and then we do have the divisive. Okay, so one we are doing the division, and another one we are smaller one we are making to the big one. Okay, so there is a thing here. So pros, no need to predefine K, and then flexible visualization. So dendrogram provides a detailed tree-like representation of a cluster relationship, which we have seen. It handles the various cluster shapes and can identify cluster of a different shape and size. So what is the cons of that one? Okay, and this is computationally intensive, slower than k-means, especially for a large data set, and irreversible decision. Once cluster are merged, they cannot be undone. So this is all for today. See you in the next class. Thank you.